Okay, now we're going to try to answer this question. Please read it. It has is not too complicated, but has several steps. So give it a look and try to answer the question. Okay. So in the following slide, if you want, you can stop the video. In the following slide, I will start giving you some clues to answer the question. As generally, I always want to highlight what is the question. Yeah. So here the question is, what is the degree of interference? Okay. So here the question is very clear. We need to know the genetic interference. So how much we inhibit these crossovers. Okay, so and they give us the following information. They give us the genes, yeah, and they don't give us the frequency of recombination. They give us exactly which positions are located, and they give us three genes. The first one is located in the beginning of this chromosome. The second one is uh, like 17 a little bit further, and the other one is even further. Okay, so that is three pieces of data. The second thing that they gave us is the amount of progeny that it will be important to calculate interference, and also the other piece of information that they gave us is the number of double crossover that they observe in the experiment. Okay, so now we need to use all this data to try to answer the question. So now that we have all this information, now we're going to try to understand. First, I will give you a background of what is interference that we already covered during the video lecture, and then I will give you the steps to answer the question. So let's continue. Okay, so to answer this question, let's remember something that we already talked in the video lecture, that is what is interference. And interference is a genetic phenomena related to linkage in which we inhibit further crossover events. Okay, and if you want to know more about that, you can watch the video lecture. How to calculate this genetic interference? So in the video lecture, we always also talk about that this phenomenon can be quantified using interference coefficients. So here you have the formula that is 1 minus the coefficient of coincidence, and here you can see the coefficient of confidence, that is observed divided between expected double crossover. Okay, so we have all the data there that we study, that we already covered in the previous slide. There are three main ideas, and from there all this information uh, uh, we just have to organize it to answer the question. Okay, so to make it simpler, I divided in 4 steps to answer this question. Yeah, and to come here with the uh, interference, the first thing that we need to get is this coefficient of coincidence. And the easiest thing that we're going to do is that we will do at the end is to take the data that they already gave us of the observed double crossover. Yeah, if you remember, if you gave a read, it was 6. Yeah, they told you there is 6 observed double crossover. However, we need the expected double crossover. To get those ones, we need to determine them, and to that we will need to have the frequency of recombination of one region and multiply by the frequency of recombination of the other region. Yeah, so we will cover that in a second. And to get those frequencies of recombination, we will need, before doing these things, we will need to take all this data and use that data to calculate the frequency, the distance between each one of these genes. Okay, so we have 2 frequencies of recombination. We will get it from here, and I will explain that in a second. And finally, the first step that we need to get. And so finally, the last step, or the first step, the initial step that we need to do is take this table to draw the genetic map using this data. Okay, and we will do that. So I showed that we're going to, in the following slides, we're going to do 4 steps, yeah, that it will allow us to calculate the interference, yeah, the degree of interference. It looks complicated, but you will see that it's pretty easy. So let's start. So let's start with the first step, that is drawing the genetic map. So they already give us these 3 genes, and these 3 genes have a specific location in the chromosome. So what we need to do is draw a chromosome. And here you can see the point number 0, so the initial section of the chromosome. We generally, when we were making maps, they give us pieces of the chromosome that we didn't know which gene was first or which one was last. Here they actually did the job and gave us already the map, and they told us that in this chromosomal map, the Y-i's, yeah, it will be located at 1.5 units, yeah. In the following, we're going to have the cat wings, that gene, CT at the 20 map units, and the TAM body, it will be at 27.5. Okay, so first thing that we did is map this, so it's much easier to do it. Now let's move to the second step. So now we're going to determine the frequency of recombination, and how we do that? Through the distance. So if you remember, we need to calculate the distance between these 2 genes. You can hear now our TA, Emilio, my baby, that is here helping me to record these videos. So here we have already the map. Now we need to find the distance here. So we have a distance here between white and curly wings, W and CT in red, and we have here how we calculate that distance. So it's 20, yeah, and where the 20 come from? From here, and the 1.5 then come from here. Okay, so we subtract that value, and when we subtract that value, we get 18.5 units. That is a probability of 0.185. Okay, so that will be the probability of that will be the frequency of recombination. Now we need to do the following, the distance between C and T. If you want, you can stop the video and try to calculate that one. It's pretty easy. If not, I will continue. So the next one is the distance between CT and T. And so we again do the same thing, subtract. So we subtract the 27 minus 20, and we get a distance of 7.5 units. So we subtract this that is in green, this value, and this one that is in blue. And we get this 0.075 probability. Okay, so first thing we draw the map, then we calculate the distance, yeah, by subtracting the value. Now we're going to go to the third step. Okay, so now that we have these 2 probabilities, we're going to multiply those to calculate the expected value of the crossover. Okay, so it's pretty easy. Here we have the expected rate of double crossover here, and just to make it easier, to not make it too long, I create this name, this here ERDC, just for this exercise. So here you have the frequency of recombination of one and the frequency of recombination of the other one. So we just multiply those values and we get this value. That is that if we multiply that one by the progeny, yeah, the total progeny, we will get actually the expected crossover to calculate the interference. Okay, so let's start with the last step where we'll calculate the interference. So now we can just apply the formula, and now the value that we already have, the observed double crossover, the one that we actually got in the experiment, we can divide it from the expected double crossover the value that we're expecting in theory, that we calculate from using all these different three steps. And as a result of that, we got this 0.751, that is the coefficient of confidence. Yeah. So this coefficient of confidence, we apply the formula, and we have 1 minus the coefficient of confidence, and this is the value of the interference. Okay. In case that you want to know, here is a summary of the calculations that I did. So you review it. Highly recommended that you can stop the video, try to think about it, try to draw it, because it's not complicated. It's just that they wanted that you think in this exercise. So now let's try to see the different options that we have, and I will show you again the question. So here, if you remember, this was the question, and the value that we got was 0.249. Yeah, so the percentage will be close to 25. Yeah, when you approach it. And that's all. If you have any question, just let me know. Have a good day and bye.